Hey guys, okay, today's lesson would be solving special systems. So far, we have solved systems which have one solutions. Now, we know that when two lines intersect at a point, there is exactly one solution to the system. Systems with at least one solution are called consistent systems. Now, when two lines in a system do not intersect, they are parallel lines. So there is no solution. Remember that parallel lines have same slope, okay? A system with no solution is called inconsistent systems. So we're going today, in today's lesson, we're going to be talking of special systems, systems that may have no solution, or systems that will have more than one solution, infinitely many solutions. So if we look at example 1, it says solve y equals x minus 1 and negative x plus y equals 2. So here we're going to solve using any of the techniques that we learned, right? Remember that we learned to solve by graphing, by substitution, and by elimination. Now, in this case, example 1, notice that the first equation, y equals x minus 1, is solved for y. So in this case, it will be convenient to solve by substitution. So we select the first equation, okay? Y equals x minus 1, right? It is solved for y. Now we select the second equation, negative x plus y equals 2. Now we're going to substitute. Instead of writing y, we're going to write x minus 1. That is substitution. So that means negative x plus x minus 1 equals 2. Now, since this is an addition, we're going to suppress the parentheses. So we get negative x plus x minus 1 equals 2. Notice, negative x plus x, negative 1x plus x, we cancel them. Now we get that negative 1 equals 2. Notice, negative 1 equals 2. Is this true or false? Negative 1 equals 2. This is false. Since negative 1 is not equal to 2, then we can say that the system has no solution. Okay? Because negative 1 is not equal to 2. No solution. Now, another way to solve this or to prove this is by graphing. Okay? Remember that the easiest way to graph is to write your equations in the form y equals mx plus b, slope-intercept form. The first equation, y equals x minus 1, it's already in a slope-intercept form. Now, the second equation, negative x plus y equals 2, to write it in a slope-intercept form, we're going to pass negative x to the other side. So we get that y equals, if we had negative x on this side, on the other side it will be positive x plus 2. Now we have our two equations in a slope-intercept form. Notice the y-intercept b for the first equation is negative 1, and for the second equation is 2. And the slope m, here we have an imaginary 1, and here we have another imaginary 1. What can we tell about the slopes? They are the same, 1. And remember, parallel lines have the same slope. So that means that these two lines, since they have the same slope, different y-intercept, they will be parallel. Let's graph them. So the first equation, y-intercept -1. So remember, this is x, y, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 2, -3, -5. Y-intercept is -1. So this will be our point, -1. The slope is 1. That means m equals 1 over 1. So that means 1 times up, 1 to the right. This will be our second point. And now we graph the line. So there we have the line. Now, the second graph says y-intercept is +2, 1, 2, and the slope is 1. That means m equals 1 over 1. So that means 1 times up, 1 to the right. Now that we have our 2 points, we graph the line. So here we have our second graph, and notice that the two lines, they are not going to intersect, so there's parallel lines. And since it has no intersection, then we know that it will be no solution. Okay? Now, the graph was just to show you that the lines won't intersect. Okay, remember that to solve systems by graphing, it is not convenient to solve all of the problems. It is only just to prove, but algebraically is better, either by substitution or elimination, okay? Now, so in this case, no solution. Special system, a system with no solution. Now let's look at example 2. Sample 2 says, solve y equals 2x plus 1 and 2x minus y plus 1 equals 0. Okay? Notice again that the first equation is solved for y. So it will be convenient to solve the system by substitution. So we're going to select the first equation, y equals 2x plus 1. Okay, we know the value of y. And now we're going to write the second equation, 2x minus y plus 1 equals 0. And then we're going to substitute. Instead of writing y, we're going to write 2x plus 1. So we get 2x minus 2x plus 1 plus 1 equals 0. Now, since this is subtraction and we have parentheses, we're going to do the distributive property. So we get 2x negative times positive 2x, negative 2x. Negative times positive 1, negative 1 plus 1 equals 0. Now we solve. 2x minus 2x, 0. Negative 1 plus 1 plus 0 equals 0. 0 plus 0, 0 equals 0. Now, 0 is equal to 0. This is true. Since 0 equals 0, okay, since this is true, then our systems will have infinitely many solutions. Okay, it has more than one solution. It has infinitely many solutions. What does this mean? Okay, Let's do this by graphing. Again, our first equation is already in a slope-intercept form, y equals mx plus b. Okay, the first equation is in the form y equals 2x plus 1. Okay. Now, the second equation, 2x minus y plus 1 equals 0. Okay, if we want to write it in a slope-intercept form, we have to leave y by itself. So the easiest is to pass negative y to the other side, and we get 2x plus 1 equals 0 plus y. 0 plus y is y, and we can apply the reflexive property, y equals 2x plus 1. So what can we tell about the first equation and the second equation? Notice that they are the same. Y equals 2x plus 1 and y equals 2x plus 1. That means they have, the two equations have same slope, which is going to be equal to 2, and same y-intercept. In this case, the y-intercept will be positive 1. So when this happens, the graph will be coinciding lines. Let's graph to prove. So y-intercept 1. Slope 2. So that means slope equals 2 over 1. That means from this point we're going to move 2 times up, 1 to the right. Okay, and we trace the graph. So there we have our graph. Now if we graph the second one, it's the same. Y-intercept 1, slope 2, 1, 2, 1 to the right. And this line also represents the graph of 2x minus 1 minus y plus 1 equals 0. So we have coinciding lines. How many points do we have in the line? Infinitely. So the number of solutions will be infinitely many solutions. Look, remember that a line is a set of points, right? How many points? Infinitely. So there you have it. So example 1, we had parallel lines. That means lines that have the same slope but different y-intercept. In an example 2, we have coinciding lines. That means lines that have same slope, same y-intercept. Now, when we solve algebraically for parallel lines, we will get two numbers. Once we solve algebraically, two numbers that are not equal. And for infinitely many, once we solve, we will find two numbers that are equal. Okay? Now, let's talk about the classification of systems of linear equations. A system of linear equation can be classified, we said, as consistent or inconsistent. Consistent equation has at least one solution. What does that mean? It means that it may have exactly one solution, consistent, or infinitely many solutions. Okay? If the system is consistent and it has one solution, then the system is independent. If the system has infinitely many solutions, then it will be dependent. Inconsistent system has no solutions. Now, the description, exactly one solution. The systems have different slopes. For infinitely many, they have the same slope and the same y-intercept. And for inconsistent, that means no solution, they have same slopes, different y-intercept. So how does the graph look? For exactly one solution, we have intersecting lines, one solution there. For infinitely many coincident lines, look, lines, two lines in the same position. So we have infinitely points over here. And no solution, that graph will be parallel lines. They will never intersect. So if we look at example 3, example 3 says to classify its system. That means that we're going to tell if it is consistent or inconsistent, and if it is consistent dependent or consistent independent. Okay, so we're going to classify. Once we classify them, we're going to give the number of solutions. We're not going to give the solution. We're just going to give the number of solutions. So what are the numbers of solution? 0 solution, that means no solutions. Infinitely many solutions, or 1 solution. That's what we're going to be saying, okay? So if we look at part A, it says 2y equals x plus 2. Now, if we go back to the description on how to classify them, systems, notice that we're comparing slopes and y-intercept. So that means that it will be easier if we write both equations in the form y equals mx plus b, slope-intercept form. Okay? We're going to write them in the slope-intercept form. So look at the first equation. 2y equals x plus 2. Okay? So we want to leave y by itself. So we divide by 2 on both sides of the equation. So we get y equals, how many x's we have here? 1. 1 divided by 2, x plus 2 divided by 2. Now we simplify. Y equals 1 divided by 2 is 1/2 x plus 2 divided by 2, 1. Okay? We have it in a slope-intercept form. So here we know that m, the slope, is 1/2, and b is 1, the y-intercept. Now the second equation, negative 1/2 x plus y equals 1. So we want to solve for y. Let's pass negative 1/2 x to the other side. And what do we get? Y equals, if we had negative on this side, on the other side it will be positive. Positive 1/2 x plus 1. Okay? Now, look at the slope. M is equal to 1/2. And B, the y-intercept, is 1. So, if we compare the slopes and the y-intercept, what can we tell? They have the same slope, 1/2, and they have the same y-intercept, the same y-intercept, 1. So we can write the following. We can say that it has same slope, same y-intercept. Okay, so if we go to the description, same slope, different slope, same y-intercept. Okay? Same slope, same y-intercept. What will be the classification of this? It will be consistent. Look, same slope, same y-intercept. It will be consistent and dependent. Consistent and dependent. That will be the classification, okay? This will be the first part of our solution. Now, The number of solutions. Same slope, same y-intercept. Number of solutions, infinitely many. Okay, and this will be the number of solutions, infinitely many solutions. Why? Once we wrote them in a slope-intercept form, both equations, we notice that they have the same slope, 1/2, and the same y-intercept, 1, 1, same slope, same y-intercept, so we can define that. Now, part B, we're going to do the same. Okay? Look at the first equation. We have y equals 2 times x minus 1, minus 1. Minus 1. Since we have this parenthesis, that means that we're going to have to do a distributive property. So we get y equals 2 times x, 2x minus 2 times 1, 2. Now we have in slope-intercept form, y equals mx plus b. That means m equals 2 and b equals negative 2. The second equation, y equals x plus 1. It is already in a slope-intercept form. We don't have to do anything. So we know that m equals, how many x's we have here? 1. And b equals 1, positive 1. So what can we tell about the two equations? Look at the slopes. We have different slopes. So if we go to the table, different slopes, then the system will be consistent and independent. And independent. Okay? Now, the number of solutions, consistent, independent. The number of solutions will be one solution. Exactly one. Okay? So, when they ask you to classify the system, write both equations in a slope-intercept form. Okay, so that you can compare the slopes and the y-intercept. Once you have that, you go to the table for the classification of systems of linear equations, and there you can easily tell how to classify them and the number of solutions. So that's it, guys. This is lesson number 4. Your homework will be homework number, I think it's homework number 7, right? Number 7, sorry. Page 409. Page 409, problems 2 through 22 even. Okay? Don't forget to call me if you have any questions via WhatsApp, and I'll help you out. Okay? And leave a comment and thumbs up on the video. See you guys.